Hello, I welcome you all to this code walkthrough session of week 9. We will start from where we left off in week 8. We saw the stream API and we used it to actually convert collections into stream and then operate upon it. So the benefit of stream was that there are primarily we observed that there are multiple benefits, but first is, let's say, you can do parallel processing, but we couldn't actually see it because we have not yet learned multi-threading. So once we do that, we will come back to this. And then secondly, it is a lazy evaluation that also we have seen. So basically you don't have to complete each step and then move to the second one. It's not like that. So you can, as explained by Professor Madhavan, that it can actually proceed. Even when the stream generation is yet not complete. So that's why basically you can operate with, in theory, you can operate with infinite length streams. So these things are there, but what was actually we have seen the benefit that we have actually experienced is if you want to apply, let's say, like if you want to work with a normal collection with, where you want to do filtering, where you, so basically depending upon any condition, you want to sort out or you want to filter out some of the objects or some of the data items, whichever is there in the collection, or let's say then suppose you want to um, apply some transformation on each of the objects. So then you have to iterate through that collection, which requires you and then you will need an iterator to do that. And if you're doing multiple such function, multiple such mapping and multiple condition checking, then the code will be quite big and cumbersome, right? But streams actually help you in that also, because the API actually is quite easy to work with, easy to code, and you just once you convert the collection into stream, then you can just apply multiple intermediate stream functions by using simple dot, right? So we have seen this over here, this dot limit, dot map, dot filter, right? So you can do this, and every time the stream is getting changed, and at the end you can finally put a terminating function and get a result from the stream, or maybe modify the stream in a certain way, right? So these things we have seen in this. So last week we stopped at the point about this optional, right? So what is this optional type all about? Line number 79. So we will start from that. So see, just a second. So we have seen this explode method and what it does. So this we have this word start long words stream, which is basically the word stream. We have this word stream. Where is that word stream? Yeah, word stream 1. So word stream 1 is this array list, right? So this word list, and from that we are creating this stream word stream 1, which is basically the stream of the linked list. Right? So from the linked list we are converting it into a stream, and this stream will contain the name of this basically the strings, right? Moriarty, Lex Luthor, Dr. Octopus, all these strings will be converted into will be converted into each element inside that stream, the word stream 1 stream, right? So in the word stream 1 stream there will be 3 elements, and these 3 elements will be Moriarty, Lex Luthor, and Dr. Octopus. So the string, it is a stream of string type, so that we have seen. Now what we are doing over here in this particular part is so here what we are doing, at first we have this stream word stream 1, and on that stream we are applying filter, so that we will only take those strings among that stream, right? So each element is the string that we just saw. So now we are taking all of those strings one by one, all of those elements, that is all of those elements one by one from the word stream 1, and then we are applying this filter condition if the length is greater than 5. So that string length is greater than 5, then only we will add it to the then only we will let it allow. So those words which are of length more than 5 will be allowed to stay in the stream, and the others one will be filtered out. And then we are applying a transformation using the map function of stream, where we are on each of the leftover strings in the stream we apply the explode function. Now what does explode do? As we discussed already, explode will convert your it accepts a string type of element, a string type object, and then it converts it into a list of characters. So it decomposes the string into the constituent character by character, into the constituent characters, and forms a list of those characters, right? So that's what explode does. So since map is being applied on each of the string present inside our word stream 1, so that means now word stream 1 is nothing but a list of strings. So list of character. It is a group of character list, I would say. So let us say the stream would look something like this. Suppose I'm denoting the stream by these two. So let's say the stream is something like this after map, that it will be, let's say first list will be Moriarty, right? So character M comma O, like this, right? So dot 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 Moriarty. I'm not writing the whole thing. So all these things, this is the first element within the stream. Then the second element within the stream will be the next character, which is, I think, Lex Luthor. So Lex, right? E, and dot dot dot, like this. Then again the third character within the stream will be the next whatever name was there. So it will be a list of, like this. So it will be a collection of, it will be a group of lists, right? List of characters. So this is what the map method after applying explode on each of the element will do. Okay. Now what will flat map do? as we discussed earlier also. So flat map will, so first of all, what is flat map accepting? Flat map is also a transformational function. So what I mean by that is, it is just like map. So map is what it is doing a transformation. On each element, it is applying some transformation. So flat map also does the same thing. On each element, it will do some transformation. Only thing is, it will also level the hierarchy. So what do we mean by that is, you only use flat map when there are list of elements in your stream. Okay, so there are multiple lists in your stream, or there is, let's say, there are multiple set in your stream, something like that. So if there are multiple lists in your stream, then we know that a list is a collection, and each collection can be converted into a stream representation by using the dot stream method of collection type, right? So within this stream, right, within this stream, I can convert each of this list into its corresponding stream, right? So don't get confused. This is the parent stream, right? So the parent stream is holding all these elements together, all these lists together. But now each of these elements within the stream, which is basically a list of character, they can also be converted into their stream, an individual separate stream, right? Because at the end of the day, it's a list, so that can be converted into a stream. So I can convert this Moriarty, this decomposed Moriarty list of character into a stream of itself, right? So that's what this lambda function is doing. It is taking each element of the stream, which is basically each element in this case is basically a list of character, and then converting them into list.stream, right? So then what happens? So then the stream will look something like this now, that I've converted each of this list into a stream. So I will have M, then O, then R, dot like this, right? We have last at Y will be there, Moriarty, right? So we have something like this. But then again, this is a separate stream. So maybe I can represent it with something like, assume that this symbol represents a stream. Okay, so this will be a stream of its own, right? Then again, I have another this Lex Luthor part. So this will be again a stream of its own, L, E, X, like dot whatever. So like this. So we'll have multiple such individual stream within the main parent stream. This is where the flat map method comes. This is where the flat map method comes in. This is where it is different from map. So now, since we are this new stream is composed of multiple substream, flat map will inherently convert this substream as a part of the main stream. It will break down that, it will flatten the substream into and compose it with the mainstream. So basically, after this line of code completely works, so the code will look like just all this will be removed. So the substreams will be just removed, and the mainstream, all the letters will be a part of the mainstream, right? So Lex whatever Luthor L, right? L U E dot. So this is how the new stream will look like. So these things we have discussed. I just wanted to discuss it one more time because I don't feel comfortable with the last week's explanation of this flat map method. So I wanted to discuss it once again. Yeah. So that was the explode method and flat map method, how they work. Okay, so now coming back to this week's primary discussion, which is optional type. So what is this optional all about? See, many times what happens is when we work with streams, okay, so it might so happen that the data that we are assuming is present in the stream, but it is not, no such data is present. So like in this example, we are generating by using maths random function and generating values using maths random function. So it will be between 0 and 1. And as discussed, Sir has discussed this example in the slide as well, that once we generate these random numbers, it will be between 0 and 1, and then we limit it to 10. Limit means basically we are taking only 10 numbers. So this generate function does what? Generate and iterate. Both of these functions will create multiple elements, right? Now difference between generate and iterate is, generate, we give a lambda, the generate method will run that lambda multiple times, and whatever the lambda is returning will comprise of the subsequent element in the stream that is getting generated. And iterate method will do what? Iterate method, we give a initial primary condition, we give a initial starting statement, a condition to terminate the iterate method, and increment condition, how to increment at each level, right? So it's like a for loop. So iterate is nothing but a for loop. So you give these three conditions, and on the basis of these three conditions, each element will be, the subsequent element of the stream will be generated, right? So these are the two methods of stream in which we are not converting it into, converting from a collection or something, but rather we are generating an infinite sequence, or maybe finite sequence depending upon our conditions. So sequence of numbers or sequence of elements, not numbers, elements. Okay. So this generate method will continuously call this random function, and it will generate infinite number of random numbers. But we just want to take 10 numbers, the first 10 numbers which are randomly generated. So if you want to put if you want to basically have a bounded stream, so with a fixed length, so then we can use this limit function. So that will, whatever value we give in the limit, that will be the maximum length of the stream. So only 10 numbers will be considered by the, will be considered to be the part of the stream, and the other, if after that the generate will not work. So only 10 iterations of generate will work. Okay. Fine. So this is the limit method, and then we are filtering. See, what happens over here is we make a condition that it is less than 10 to the power minus 4. The number that is getting generated must be less than 10 to the power minus 4. Now, since random is generating from 0 to 1, generating a number which is less than 10 to the power minus 4 has quite a less probability. So if all the numbers, let's say all the 10 numbers that we are considering are none of them are less than 10 to the power minus 4, then the stream will be an empty stream after the filter method has executed, right? So in such a situation, the max function will not be able to compare anything. So max will not return any maximum value because the stream is empty. So if we go to the definition of max now, you see that max will returns an optional describing the maximum element of the stream or an empty optional. So it will return either an optional which is the maximum element of the stream, or it will return an empty optional. So what is this empty optional and what is this optional? So see, while working with streams, since we can get into this kind of situation, Java provides you with a separate special kind of feature which is an optional type. It is a new type. I mean, we could have stored it into a simple normal variable, double type variable like maxrand. But the thing is then, the return value might be, we could have set it to be null or something like that. But that's not how Java performs. While working with stream, if we are not sure about that the stream might be empty, or we are not very sure about what element is there at each time in the stream, it is better to use an optional variable to catch the value from the stream, the return value from the stream. And the reason for that is, in this case, if we will have this optional variable, either it will be the return maximum double value, a double type, it will work like a double type variable only, or it will be an empty optional. Please don't get confused. This has also been described by Professor Madhavan in the lecture, that empty doesn't mean null. Okay, this is the primary difference. In fact, so that we don't have to deal with null, because sometimes in this kind of tricky situation, when working with streams get a little bit trickier, when you are working with large code, enterprise level software kind of coding, so where you are dealing with a lot of streams and let's say a little bit cumbersome code. So then what happens is you might run into null pointer exception because of this kind of situation, right? So because if null is there, so we don't have this null, so that we do not have to deal with this null problem or null pointer exception. What we generally do is we keep it in the optional type, and this optional will help you with some methods, that we will see as a part of this week 9. These methods will help you to actually operate upon this optional variable, and you can use those methods to launch specific action depending upon whether the value present inside this optional variable is a legal value, that is it actually a double maximum number, or is it just an empty optional, that is whatever was there in the stream, the last method could not return the required value because of some reason. Maybe the stream could have been empty, maybe it could not find the required value it was finding. Whatever it is, the correct result could not be returned back to the variable by the stream function, and that's why the optional is an empty box, right? It is not null. Again, it is not null. It is a separate thing which is internally known to Java, and that is a separate state, which is basically we call the optional is an empty optional. Okay. So now we will come to week 9 part and see how it happens. So assuming this optional maxrand is basically now an empty box which is not storing any double type number, because assuming this is a very strict condition to maintain, right? So then what we will do, maxrand.orl. So as I just told you that we have multiple methods. These methods will help you to deal with this concept of an empty optional, how to extract the value that is stored in it. So what will maxrand.orls method do? So orls will basically return, so whatever, so let's say I have this double fixed rand, right? So basically you wanted over here to store the value inside a simple double type variable, but we introduce this new concept of optional. So one line later what we are doing is we are doing the same task. We are storing the value in the double type variable, but just we had an intermediate step. We introduced an intermediate step, and in this intermediate step what we are doing is we are saying maxrand.orls minus 1.0. Right. So what does this mean is, if I have stored the optional type, I have stored the value in the optional type. Now if the maxrand variable is storing some legal double value, then that double value will be returned into this fixed rand. But by chance, if maxrand is an empty optional, so in that case this orls part will get triggered, and minus 1.0 will be returned into the fixed rand variable. So if you work with fixed rand, you can just put a if condition and check, and if you see that the value of fixed rand is -1, then you understand that the stream that the stream on which we are operating could not return a legal double value, right? Maybe due to different reason, but yeah, that is the case. So this maxrand.orls is one such method for optional, where you can specifically put a value that you want to be returned in case the optional is an empty box. Another method is this throw exception method. Like I have not gone through each of them. All those things will be there in the slide. You can see sir has given many such example. One such method is if present. So orls method is getting triggered when the value is empty, right? And if present will get triggered if the value is present. So if a value is there, so then if a legal value is there, then I want to do something. So another one such method is if present or else. So what is this if present or else doing? So you can provide both the condition. If present do this or else do this, right? So just a second. Fine. So as we were saying that this if present or else method helps us to provide both the condition. And if you see over here, this what we are doing is if present. So maxrand.if present. So you do this line of code, pass this lambda or operate this lambda. So this lambda is saying what results.add v. So we have defined the array list over here, results. So if the double value is there in the optional type, you basically add that double value into the results array list. Okay. And otherwise, if it is not there, then you simply print the illegal statement on the console. Fine. Okay. So this if present or else is also one method to deal with this optional type. Now we will see a another part of our stream API, which is basically converting streams to collection. So initially we learned about how to convert a collection into stream, so that we can apply different function in a easier, less cumbersome, easy to code way, right? And then we saw some other things as well. But then now we need to convert the stream back to a collection. Suppose now our work with the data, I mean, we have done whatever changes we want to do in the data, whatever filtering, mapping, all those things are done. Now we just want to convert the stream which we have, the leftover stream, that is the modified stream. We now want to convert that modified stream into the collection which it was earlier, or maybe into a new collection, whatever. So we want to convert the stream back into a collection. So if you want to do something like that, so how to do it? So we see that we have this, in this example, I am using iterate method to generate a random stream. These are the conditions that it will start from 1 and the value should be less than 625, and each element will be defined as a perfect square, I square. So I will start from 1, 2, 3, 4, 5, 6, I will go, and 1 square. So the stream will be consisting of values like 1 square, 2 square, 3 square till the value itself goes to 625, right? Which is I think 25 square. So we have 1 to 25 square numbers from 1 to 25 square, which is basically 25 numbers we will have. Okay, so we have a finite stream of 25 numbers where each number is a perfect square. And then what we want to do, we want to convert this stream into a collection, into a list, right? So this is the way to convert it into a list. First of all, we have to define the reference variable accordingly. So whether we want to convert it into a list, a set, a map, whatever. So we mentioned that reference, followed by we have the stream name, perfect square, followed by dot collect. So this collect is actually the method which is dealing with this conversion of stream into collection. So we have this collect dot, not dot. In the collect, we have to pass an argument that what type of collection do you want to convert your stream into. So I want to convert it into a list. So collectors.toList is used. So these things you have to get acquainted with by practicing, right? So collectors.toList. So this toList will convert our stream into the list type collection. Now next example is with a set. Same thing here we will do with just collectors.toSet. We have a random stream and then we use the collect method and pass collectors.toSet in place of toList, right? Here I am using, just for variability, we have used generate method. Generate method will call this lambda or method reference, whatever, multiple times. And then since generate is not a finite stream, right? Generate will continuously call the method you have supplied, or the method reference you have passed. It will be called multiple times, and then we have to basically, if you want to, since you want to convert it into a collection, obviously you have to deal with bounded streams. You cannot work with unbounded infinite length stream, right? So therefore, since generate will create an infinite length stream and there is no specific termination condition, so in order to terminate any stream created by generate, we use the limit method. So we are taking only 20 elements that are created, the first 20 elements, and then we will use the toSet method to convert those 20 elements into a set. Okay, fine. So then what we are doing is a linked list. Now see, both of these, at line 94 we converted the stream into a list, at line 96 we converted into a set, right? But then we can use the result and result2 variable to actually operate, I mean, call all the list and set method correspondingly. But now we want to convert it into a concrete type as well, so that we can have more functions to actually operate upon, right? We can, so what I mean is more function means all the function which are there in list will be there in linked list as well. But linked list again will have some specialist function which depends upon the specific algorithmic definition of linked list, right? So those function can only be used when you are storing the stream into a concrete linked list type reference variable. So now in order to convert into linked list and not a general list, the syntax is a little bit different. Again, we generate a stream using this iterate method, like similarly. Okay. Then we use this collect like usual. Now again, collectors is still fine. Then we are not doing toList. Unlike the previous case, here we will do dot to collection. And then again inside to collection, we will pass the parameter of the linked lists constructor. So linked list scope result, I mean this operator, which is basically kind of a method reference to the new operator of linked list. So this syntax basically means you are calling the constructor of linked list. So that means you are basically creating a new linked list, and in that linked list you are putting the values of your collection of your stream. Okay. Again, see, this is something a little bit differently done. So here in the iterate method, we have passed only two things. We have passed the initialization condition and the initialization statement and the termination condition statement, but we have not provided the initialization statement and the upgradation statement, but we have not provided the termination condition. So since we have not provided the termination condition in iterate, so this again will be nothing but a unbounded infinite stream. So again, if you want to convert the infinite stream into a collection type, then you definitely have to make it bounded. So then again, we are using this limit function. Okay. So these are just syntactical things. Now, if you want to convert into a map, then again it is a little more difficult than the other ones. So what we are doing here is, so we are using the stream.generate like usual. Now this is a little bit complex function, not complex, I mean more complex than the ones we have used till now. So this has nothing to do with the map concept. It's just we are generating a fancy stream. So let us see after this. So till this point we have the stream, right? So where the cursor is blinking now, so we have generated the stream at that point. So once we get the stream, then we are again, since it is generate, so we need to limit the stream to make it bounded. So we are taking 20 elements as usual, then using dot collect collectors. Now here we will use toMap, right? toMap. But now map is what? Map has two values. So in order to have the key value and two items, the first is key and the second one is value. So we need to define how to generate the key as well as the value in the map, because you essentially have a stream, and that stream is nothing but a stream of what? A stream of in this case it is a stream of strings, right? Strings type. So we have this R string. So this stream will be nothing but a stream of strings, right? So since we have a stream of strings, that is a single value, single string is there in the, I mean, each element of the stream is nothing but a string. And if you want to store that into a map, then we have to make something, we have to tell the map how do you want to define the key and how do you want to define the value. So this is the way we do it. After we write collectors.toMap, inside this we pass two lambdas again. Okay, so we can pass two, I mean, this function.identity, just forget it. Let us now write it as, sorry. Okay, so this, let us, right? So something like this. So the first one will tell you, first lambda will tell you the key definition and the second lambda will tell you the value definition. So the key is I dot length. So since each element, or I is representing each element in the stream, so now each element is a string, so string dot length. So the first element of your map is an integer, and that is the length of the string. Second element of your map is, which is basically the value of your map, is the string itself, which is basically a string type. So that's why you see the map is defined as integer and string, right? So the first is the length of the string, second is the string itself, and I cross I. Now when you are dealing with this kind of stuff where the value is itself the entity, right? You don't want to have any fancy thing, you just want to keep the whole entity as your value. So then we can use, in place of this, we can also write function.identity. It is use if I mean, I've just used it so that you don't get confused if you see this code somewhere in some book or in some places. So this is a fancy way of writing I or Y. So basically you're putting the object as it is, right? So in either way you can write it, fine. So that's it. So this is how you convert your collections into stream, and then you can operate upon them, and then at later, once your operation is done, all your task is done, then you can convert back the collection into the required, convert back the stream into the required collection you desire. Right? So this is, so that's how we work with streams, and we will come back to stream again later after we learn multi-threading. But let us now move to the next part, which is a new topic, which is basically file handling. So how we will work with files and Java program, right? So file handling is a very important thing with, I mean, with respect to any programming language, because it helps you in dealing with storing data to a file, reading from a random file, right? So this helps you to make your code more dynamic and more usable in many situations. So how Java provides you this facility is, we have these streams. Now we have, so please don't get confused about it, that the streams that we will learn as a part of file handling, they are not the stream that, at least they are not exactly the same stream that we just talked earlier, right? So these streams, let's say it is a byte stream, you can see, you can understand it as a stream of bytes, and those bytes are the, I mean, any data that you are writing, that is essentially a collection of byte, right? And that byte we are converting, and not converting, assume that we have a sea of these bytes, a stream of these bytes, and these bytes will be used. This is the representation, and on those byte stream we will do reading and writing. So when we write to a file, we write a byte stream. Essentially, internally we are writing a byte stream, or if we read from it, we read it in the form of byte, right? So there are multiple methods, multiple wrapper function which will help you to read it in a specific desired way. So let's say you want to read an integer, you want to read a number, whatever. You want to read a string, different types, writing a string, writing an integer, writing an object, reading an object. So all these functions will help you with all these facilities. But essentially, at the end of the day, internally what's happening is you are writing and reading byte stream. Okay, I mean a sequence of bytes. So that's why we call it as a byte stream, or input stream, or output stream. So the stream word will come in as a part of this file handling module. But don't get confused, this stream is not the same stream as the one we just studied earlier. Okay, fine. So let's start this file handling part. So how we basically work with file is, in Python you guys have simply written that open function, and you would have got a file handler, and that file handler can be used to read and write into the file. Java, it will be a little more difficult because it is more towards the system, more towards the machine. You have more customization ability. You can do multiple customization, multiple performance choices you can make, but then again you have to write a little bit more tedious code, right? So what do we have over here is, so in order to, let's say, read from a file, we will use an input stream class, and in order to write to a file, we will use an output stream class. So file input stream and file output stream. So this file input stream and file output stream are basically the primary reading and writing classes, or to operate upon files in Java. So what I'm doing is, we are creating a new file input stream object, and inside the object we are passing the parameter as the input.txt files path. So I just took an example of a complete path, so that I mean, you can write a complete path also, you can write simply this, you can delete this also, this whole highlighted part. So then input.txt will be created in the local directory wherever your program is stored. But if you want to write or read in from or into a particular file, then you have to provide the complete directory. Okay, so now we have given that, and we have got this file handler, file input stream fin. Okay, now this is the file handler. You cannot use this file handler directly to write or read into, sorry, this is input stream, so anyway it will be for reading. So you cannot use it directly to read it. So you need a methodology to, I mean, which will help you with reading. And the file handler is will basically tell that, tell that part of the, this new thing that we are talking about. In this case, it is a scanner. So the file handler will associate the scanner with the particular file. But you need a scanner to read from the file. Likewise, when we will write into a file, we will have file output stream, and we will have a handler. So that handler will have to be associated with another function, another class object, that class object will basically help you to write into the file, but that class object will associate itself with the output file handler, and that file handler will be the file output streams object. Okay, so but you cannot use the direct file handler to write into the file. Just like here also you cannot use the direct FIN, the direct file handler which is FIN to read from the file. Okay, so we need a scanner. So how to make this scanner associate with the file? By using the file handler. So you see new scanner FIN we are writing. So your scanner will basically be associated with that particular file. Likewise, we here define a new file output stream as we discussed. So this is output.txt. Reading was from input.txt, writing is to the output.txt file, a new file. And then in order to write also, since as I said that you need something else, this something else, while reading it was scanner, while writing it is print writer. So you have this print writer class object which is helping us to write into the file. Okay, so this is done. Now, how will we basically read? So first of all, we will read from the input.txt and write the same data into output.txt. That's what we are trying to do over here. So you have this hasNext method, like scanner has this hasNext method, right? So you write hasNext, and then as long as hasNext will check if there is any value present in the input.txt. So every time while loop is running, scin.hasNext will check if the file input.txt still has some unread data. If some data is there which is unread, then hasNext will return yes, true. So then we will go into the loop, and here we are using a next line method to read. So this is like normal scanner reading from console. So you are reading line by line. So as long as you have the as soon as you get an end line, you go to the next line. Till that point we are reading the line, right? So scin.next line will read the whole line before we go to the next line, right? So the whole line will be read and stored in the string variable, and then we are simply using pout, the print writer object, to write the value into the output.txt file. Now how do we write it? So see, this is beautiful. We are using the println method. So just like the system.out.print or system.out.println, we are using the same println or print method for the print writer object, right? So this will print the value of your line string into the output.txt file. Fine. So scanner method when passed, a file handler of reading file handler or input file handler when passed into the scanner method, scanner object. So then that can associate itself with the reading file, and it can read through the file by using the next line, next int, next char, next double, all this method we can use. And then again we can use the file output stream to create output file handler, and we can wrap it around the print writer object, and then use that print writer object to write into another file. And the functions that we will use to write is again this println print. Actually print writer also has a write method, but you can use this familiar ones also, which is print line or print normal, println print, all this method. Okay, so simple code. We have seen the things, but now let us see this part now. So let us run the code and see what happens. Let me just check before that do we, so input.txt, let it be there. Okay, so we have this input.txt file, right? See, input.txt stores these numbers, right? So from these numbers we will read the value, and then hopefully an output.txt file will be created if the code is right, and inside that file we will have these required values written into it in the same fashion, right? Okay, so let us run the code and see. Yeah, so not this one. So you see that the code has run successfully. There is no error or no warning or anything. It is successfully executed. So hopefully there should be an output.txt file created in my local directory. So here you see the output.txt is created. So let me see what is getting printed inside this. Nothing is there. See, output.txt file, but there is no content inside it. Input.txt is fine. Yeah, input.txt has these values, but suddenly output.txt does not have any value. But the file is getting created automatically, right? So that means let us go to the code and review it. So here output.txt till here it is getting created, means this file output stream is working. All these things are fine. You are reading also. The code has also executed successfully. There is no error or exception. So then what is happening? See, this is very important, and many of us make this mistake. What happens is when you are using this file input and output, right? We have internal buffers. So which is, local to the program. Local to the programming environment of Java runtime system. So these local buffers will store the value which you are writing into using the file output stream file handlers. Right. So why the buffering is done, that is not, we will not discuss those things in detail, but there are some system requirements, and for efficiency purpose and security purpose, Java internally at first, whatever you are writing into a file, it will be stored in a buffer area, and then that is basically will be a part of your file handler only, and then that buffer will be, once you basically flush the buffer, all the content of the buffer will be passed down to the appropriate file in which you are trying to write, right? Or if the buffer is closed, then also it is fine. So here what happens is, whenever you are reading before the buffer is getting closed, you are again reading and writing into another file. So the values which you are writing is not getting flushed out, right? Because we have not closed any of the file handlers that we have used. We have not closed scin, fin, fout, none, pout, right? So basically fout or fin. So we have not closed those things and therefore the value is not getting flushed out. And since the value is not getting flushed out and the program is getting terminated, that's why at the end of the program, when you go to the output.txt, you are not finding any value written over there. So because the value is already stuck inside the buffer, so in order to get the value, you need to close the buffer and flush the buffers. I mean, close the file handlers and flush the buffer. So that's why we have used. I mean, you have seen over here. So scin.close and pout.flush has to be done. So this is very important. Your code may look fine, but if you don't do the flushing, then this will not be reflected. So what I can do over here is, so I want to close the buffer and flush the contents. So yeah, so we will just simply flush the buffer after flush the file handler after the work is done. So we will write pout dot flush, and the scanners work is also done. So we will basically close the scanners dot close. So these two things we have to do. This is very important. If you don't do it, it will not be printed in the file. So now if you run the code once again, so there is no exception or error. The code has executed successfully. Now let us go to output.txt. As you can see that everything is proper and printed in the way input.txt had, right? Yeah. So this is very important, flushing and closing of the handler. Okay. So but there is another way to do the same task, and that is worth discussing. So let us do that. By the way, so as you can see, we have used this throws IO exception over here. So why we have used that? Because this working with file input stream, file output stream, they throws exception. So if you go to the definition, so you can see over here, public file input stream string name throws file not found exception. So since this file not found exception is there, right? So we have to handle that. Either I have to put all these things inside a try catch block, or I have to write an appropriate superclass type of exception with the throws keyword in the main function, right? So therefore, because these are not runtime exception or unchecked exception. All of these are checked exception. So you know now what are checked and unchecked exceptions. If I do not give anything in the throws keyword, then see this is showing error. So either I have to provide try catch block, right? Either I have to provide try catch block, or I have to put over here throws file not found exception, right? So then it works. So that means that file not found exception is not a unchecked exception, it is a checked exception, right? Otherwise, this, even if I do not mention anything, then also this throws keyword would, I mean, if I do not mention the throws keyword, then it would not have shown the error if it would have been an unchecked exception. So these things are discussed already, but there is one more thing which is also discussed in the previous session, which is basically when you are using the throws keyword, when you are again so when you are using the throws keyword, you can actually write any super type exception, right? While defining the method, it is not that. So don't get confused. While defining a method, so like when we were using this clone method, right? Clone not supported exception was there. I mean, if you do not use a marker interface. So we told you that the throws method can store anything which is lesser or subtype of the actual definition of clone method. So let's say in the object class clone method, whatever definition is there, so let's say throws some XYZ kind of exception. In the parent class, a method is defined with the throws keyword, some XYZ kind of exception. In the subclass, if you redefine the override the method, then you can only write throws. I mean, as a part of that method definition, you can write throws anything which is subtype of that main exception type, right? I mean, the parent class definitions exception type, whatever is given, you can write a subtype of that exception type in the subclass's overriding method definition, right? But here, when you are not defining the method, that is happening inside the class, inside the subclass when you are defining. And that is happening because basically since you are coming to a subclass level, right? So you might have to chain up the exception. That's why we are keeping a subtype of the main exception type. But when you are when you are defining throws keyword in case of a catching function, so this main function has nothing to do with file input stream, output stream, all those things, right? It is not a definition within a subclass. It is nothing. It's an independent method inside an independent class called code 13. Only reason is I have to mention throws keyword over here is because we are writing some lines of code which might throw an exception inside the main method, and we are also not handling it. So in this kind of situation, I must take care so that the throws keyword mentions such an exception type which can catch all the exceptions that might get generated in the main method code, right? So whatever might get generated in the main method code, that should be able, I must mention a type of exception which must be able to capture any type of exception that is getting generated as a part of the main method, right? So therefore, we can only write anything which is either the same type or the super type of the exception that is actually thrown by the methods inside the main method. Okay, so don't get confused. Think in a peaceful manner. When you are defining a method in the subclass, the exception type that you have to define as a part of the function definition using the throws keyword, that should be a subtype of the parent class's exception type used in the method definition. That is happening when overriding. But when it is not about overriding or anything, but about usage of the function which might throw exception. So when you are using those function, so wherever you are using those function, you have to take care that in that scope where you are using those function, you have to mention a higher or more wider level of exception variable or exception class, so that any exception being thrown inside those method or inside that scope is catchable by that particular exception type which you are mentioning in the throws keyword. So here I can only write any exception type which is a super type of file not found exception, but I can never write anything which is a subtype of file not found exception, right? Because input stream is throwing file not found exception. So IO exception is nothing but a super type of file not found exception. So I can write IO exception also. right? I can also write simple exception because that is the parent class of all exceptions. That is also fine. But I cannot write anything which is subtype of that. Subtype of file not found exception, because file input stream is throwing this file not found exception. So I hope that is also clear. Now what I was telling is, let us come back to that. Without using this this flushing and closing, we can actually write a statement in such a manner so that closing of all this file handler and flushing, all these things are mostly taken care of automatically. And the way to do that is again using try catch. But here it is a little bit different syntax of defining the try. This is what we call try with resources. So whatever resources, if there are resources which you want to handle properly and you don't want to bother yourself with manually handling those resources, which is basically in this case file handlers. So in that case, what you can do is you can write up this first bracket open and close, right? And then you have the normal try catch curly braces. But let us go one by one. So we have this first bracket open. Now once you open the try first bracket, you write all the resource type variable which you want to be handled by the try block automatically, like closing, flushing, all these things. So you need to mention that as arguments of this try block. So try first parenthesis open. Then I will come down here where all my file handlers are done. So I will close it over here, right? So this closing is done. Now I will write, so I mean the try blocks curly braces exception part. So like this, so basically this. I can write this and then finally I will end the try block. Then I can also have this catch block. Now since anyway we have defined this try catch block, let us handle the exception also. So that was file not found exception, right? And we told you that whenever you are using catch block, always remember, try to use the most subtype or most narrower type of exception. Because that will help you in specifically pointing out what kind of error or exception has occurred, and you can write the handler related code. So whatever code will be written inside the catch block, the code that I'm going to write now, that can be handled in a more specific and customized way, which is graceful handling with respect to that specific exception type. Okay, so I'm not writing anything specific, but that is the way it is actually done. Okay, so since we will just using it for we are using it for formality, so simply just I will print the stack trace if an exception happens, and then I can remove these throws anyway. So see, we did not use the try for just handling the exception, we used it to handle the resources automatically. What happened? Just a second, let me just sorry, yeah. So what's happening over here is, since file not found exception is a subtype is there, we also have to handle the super type, because that might also get generated. The error is also showing that. If you come over here, you see that unreported exception, IO exception must be caught or declared. So some method is also defining the IO exception also. So we also have to handle it. So let us handle it in another catch block. I could have also handled it inside the file not found exception itself, but let us do some good practice. Let us handle it separately. IO exception e dot. And so this is both this exception type or any one of the, I mean either both of them or the super type, IO exception type, you have to define in the catch block, and then you can ignore the throws keyword. So this is how it can work. Now I don't have to do any flushing or closing, or I mean separately or manually. It can be taken care of by it will be taken care of by the try with resources block over here, right? So if I go to the output.txt and delete everything now, and then again rerun this code without any flush or close statement, then also see the result will be created. You see output.txt, it is working, right? So this is a more preferred way of working with multiple handlers, because you don't have to worry yourself with manually closing and flushing all of them in a complex program, right? Everything will be taken care of by try. Okay, fine. But one important point is, see, the try will only flush it and all these things will be done once the program is over. I mean, once the try block is over. Okay, without any exception, if the try block is over, then only these works will be done automatically. But if the try block is not over and inside it only you want to work, so let's say here what we are doing, inside the try block we are running a while loop, reading from input.txt, and in this line we are printing to output.txt, right? But let us say that if we again wanted to read the value printed in output.txt, suppose, or let's say if you want to copy the, so let's say another read statement I want to do from output.txt, make some changes in the read value and then maybe copy it to output2.txt, another file, something like that I want to do, and then I plan to do it over here only. So then it will not work. Why? Because here the try block is not over. So since the try block is not over, that means the flushing is yet not done. And if inside this try block only at line 15, 16, within this line only, if you want to again read from the output.txt, at this point output.txt is empty because the flushing is not done. Got the point? So the flushing will only be done from, once the try block is over working, right? So then the flush will happen. So if you again make an intermediate read before the try block is over, then the flush has not happened, and then essentially you are reading an empty file. Okay, so in such a situation you have to manually write flush, which we will see in the next code as well. Then you have to manually write flush whenever you want the data to be written into the file. Whenever, at whatever time you want it to be written available in the file, you have to write a manual flush. But then also this try with resources is better, because then you can do manual flushing of the files that you are working with, but you don't have to take care of all the files that you might not be needing manually flushing or manually closing, right? Fine. So let's go to the next code. Okay. So here we will see some different outputs and input stream and their functionality. So basically we are reading and writing from the file. So we have the file input stream and file output stream are the two primary things. Now that is fine. But again, on top of that, we can wrap around the input stream and output stream with multiple different kind of streams, which will provide different functionality, right? So as I told you that file input stream and output stream cannot be used independently without using a scanner or print writer. And likewise, we just like scanner and print writer, we have other classes, other streams as well, which can provide varied functionality, and we will see some of them in this part of this code. Okay, so see what we are doing over here is, so we are using the try block as we just learned now, so that I don't have to bother myself for all of the streams. So what are we doing in this code? So general overview of this code is, so we have this data.dat file. Okay, by the way, this .dat extension, .binary, .bin extension. So these are generic, I mean not generic. So binary extension is nothing but a file which is storing binary data, right? Now what is binary data? Binary data is, it's not in the form of, let's say, integer, or I mean it is not just like a collection of integer. You cannot see the file like that. It is a collection of binary number, but at the end of the day, all files are collection of binary number. But this is just intermediate representation or logical representation of files. At the, I mean, really, if you see that all files are basically .binary files only, right? But in the code, when we write .binary file, some methods might directly work with .binary file, some class may directly work with .dat file. These kind of things are there. Some might work with text file. But here it's not like that. Here in this examples, whatever we will do, you can do it with text file, binary file, .dat file, interchangeably you can use. Okay, most of the things that we are doing now. So anyway, we have used this .dat file. Dat file is again a generic file type for storing data, any byte type data. So dat file is also a collection of byte. Okay, so you can just consider it as a text file. You can also consider it to write objects that we have not seen now, and we will see in the next code how to write objects into file. Right? Now till now we have seen writing numbers or string, but now after this we will learn writing object after this code. Fine. Coming back to the main code, what we are doing over here is, we have this data.dat file, and we have this source.dat file. Now data.dat will store some famous line from some novels, and source.dat will store which novel we are talking about. So particularly, so the names of the novel will be stored inside source.dat, and data.dat will be the line corresponding to the novels, and this will be done in a arranged manner only. So whatever will be the first entry in source.dat, I mean the name of the novel, that particular novel's famous line will be there in data.dat in the first position. Right? So one-to-one positional mapping is there. So two files, source.dat and data.dat. Now we will at first write into them. So that we get familiar with reading and writing of this data files or text files, we will both do reading and writing as a part of this program. So therefore, since we will write into the file at first, because there is no data in these two files, so in order to write to the file, we will use file output stream. So that's why we are opening two data files using the file output stream object, right? New file output stream. Now we are doing two different things. We do two different file handlers. First one, we are using data output stream. So data output stream is a new kind of wrapper stream class. What it does is, file output stream can only do, I mean when you are having a file output stream, and with that file output stream, initially what did we do? While using previous example, we only did it using print writer. Print writer can write using the print function, right? But data output stream can write using directly write primitive type values in the file. So you can write next int, or next, not write int, I think, yeah, write int. So if out.data, let me just check once, if out underscore data dot write int. Oh, where am I writing it? If out underscore data dot. Yeah, so you see over here, write boolean, write byte, write bytes, write char, write chars, write double, float, int, long, short, right? So all this type of writing. So if you want to work with such a work in such a program, let's say you want to work in a PDS algorithm kind of program, in which you only need to write let's say integer values into a file, which will, these integer values are nothing but the length of a graph edges, right? Weight of the graph. So in such a file, we'll only have integer values, right? So you want to write such a data. So it is better to do that as file dot write. I mean, whatever write int should be used in a, I mean, if you use write int, it will be better. Why? Because then you can, while reading from it, you can also read it, and next int, you can use the scanner classes next int to read in the same integer format only. So if you want to write a specific kind of primitive type value, then it is better to use data output stream, because you get all these function, write float, write double, write chars, write all these things, right? Even if you write using a normal write method, or that is also fine, but then again, while reading, you have to be careful about what function you use. Okay. So data output stream, the benefit is, this new thing is, it provides you with primitive type writing functionalities into the file. Okay. So if you want to work with only a specific kind of data type, right? So then you can use this data output stream to write into the file using those specific method for each data type. So if out.data is done, data output stream, if out.source, for the source file, the file handler that I'm using is just like the previous one. Just for the sake of taking the same example, we have used the print writer of file output stream. So now we are coming to file input stream. So once we have written into the source.dat and data.dat file, then we have to read from the source.dat and data.dat. Only thing is, now after reading from these two source.dat and data.dat, what I want to create is a new file, file1.dat, and that file1.dat will store the name of the novel and corresponding line famous in the novel side by side. So this is how I want to create the new text file, by reading data by reading the names of the the books from source.dat, and by reading the text from data.dat. Okay, and placing them one by one. So I will read from both of these particular file in which I have written. Then I will write in an arranged fashion that which line belongs to which novel or which story, and I want to arrange it and write the arranged data into the file1 file. Okay, so therefore, in order to reading from these two files, source and data, then again we need file input stream file handler. So that we have done. Now again here also we have introduced. So first is scanner, the SCI and source is scanner, but SCI and data is something new. So which is push back input stream, and then buffered input stream. These two things are new. So what is buffered input stream doing? The effect of buffered input stream is a little bit difficult to observe, because this is something, as sir has also explained, that whenever you are buffering, that means you are basically reading a lot of data. While reading SCI and data, whenever you are issuing a reading statement, not only a specific part or specific byte will be read, some later part will be read and kept and buffered, so that next time if you read similar item, all the part need not to be read every time. It maybe some part need to be read and most of it could be supplied. So this will help your throughput of the program. It will help your efficiency of the program. So buffered input stream doesn't create any observable difference, but when you are working with huge data set, then buffered input stream can significantly improve your timing. So that is done, buffered input stream. After that, we are using this pushback input stream. So this is very essential for this code. See, what pushback input stream does is, as we have already we have seen in the lecture, pushback input stream is very essential for tokenizing, work like tokenizing and this compiler kind of work. Now why? So what happens is, let's say you have this stream of bytes or whatever values. Now you are reading from the stream, and then suddenly some value you read, that is basically a value which should be read in the next iteration. So this is not corresponding to your iteration, but now you have read it already. So what to do? And from stream you are reading means you have pick it up from the stream, and you cannot pick it down. Under normal condition you cannot put it down, right? So since you have already read it, and it should have been read by the next iterator or next iteration. So therefore I somehow would want now to put the value back into the stream, right? So this is only allowed for pushback input stream, and that's why you call it pushback input, right? So pushback input stream helps you in reading something and then putting it back if you realize that this value should have been read, should be read after some time, right? Because after some time means in the next iteration. So like this happens in compiler a lot. So let's say you have this Java compiler which is taking the value, right? So you are writing public public, then let's say there is a space class code 14, and then as soon as you observe this curly bracket, you see, okay, the class definition is over, now the class body is starting. It is going through scanning one by one, right? The compiler will go and scan one by one. But as soon as it sees the curly braces, it understands that the definition is over. Now we will come to declaration is over. Now we will come to the definition. So how it does that? How it identifies that? So that is because we read this and put a condition that if this is the case, then you basically start with the class body. But now the problem is, since this value is already read, it is a part of this current class declaration statement only, suppose. Okay, but I don't want it to be that. I want it to be done in the next read, and it should be a part of the class body. So then I can put this value again back into the stream if the stream is a pushback input stream. Got the point. So this is the issue. Fine. So now we have understood this, that so therefore pushback input stream help us to put the value. Once we have read it, we can put that value again into the stream so that we can read it again later, and we will see the use of this once we proceed with the code. It will be much more understood in a better way. So that was pushback input stream. Buffered input stream is for performance based optimization, right? Right, so these are the two different input stream, and then for the other source one I am using scanner as it is. So we wanted to display all the types of file operation that can be done. So for output, you can either have this data output stream, file output stream thing, or file output stream will anyway be there. Output and file input is the primary thing, so that should be there. On top of that you can wrap it around using data output stream, or you can wrap it around as a printer. Then you use different functionalities. The printer will help you with print and println method, but data output stream will help you writing the specific primitive type data, like let's say write boolean, write integer, all these things are there. Okay, then again you have this in case of reading, in case of input stream, that was about output stream. In case of input stream, again we are using two examples. Either I am using the scanner just like before, or and in the other case I am using these two separate input stream. One buffer input stream, we will not see any direct result or direct effect, but it is helping in its optimization purpose. Just assume it like that. And pushback input stream, we will see how it is working. We will use some specific functionalities provided by it. Right? Okay. Now, so then we have the third file, as I told you. So we will, in the source.dat file, lines will be given, the famous lines in each of the novel, and in the source.dat file, the corresponding novel's name will be given, and this will be in a serial order. So what I mean is, if the ith novel name is there in the ith position in source.dat, then in the data.dat file, the ith position will be given to that particular novel's famous line only. It will not be in a jumbled fashion. Okay. Fine. So now, since we have these two files and we have already set the reading and writing handler into it, now we will read, first of all, we will write into this handler the data that we are talking about, and then we will read the same data from these handlers these files one by one, and then arrange the data in a let's say novel name, and the corresponding famous line corresponding to that particular novel will be written side by side, and this whole arrangement will be written inside the a new file which is called file1, I think. So file1 dot that this file we are creating. Inside this file we will write the new data which is being constructed by reading data from that data.dat and your sources.dat, right? Okay, so now therefore we are creating a file output stream, since in this file only we will write, and we are using a print writer. So these are the lines, and so corresponding string and the sources, each line and the corresponding novel name, right? Right, so we have these datas and the corresponding sources, as we were telling, right? So now let us see how we can write it to the corresponding source file and the this data file, right? So see that while writing, we have set the data output stream for the data file and the print writer for the source file. So since data output stream will write, I mean, the way how data output stream works is, you can write, as I told you, specific types, or you can also write in the form of byte forms, right? Again, I mean, in the byte representation of an array. So this is one way. We are basically displaying multiple ways you can write by using these different class handlers, right? You could have also used the let's say what I'm saying is, so we will write the source. So the source is the data is using this data output stream, right? So the data part, which is this S1, S2 and S3, right? So this S1, S2, S3, we could have also written it using I mean the write line. So in place of this byte form or anything, we could have also written the corresponding, let me just, what I mean is, we can write something like about data dot write, let me delete that only. Right. So you see this, we have these different write methods to use. So I can write, this first one is coming as a write byte kind of array, byte array, right? So what we are doing by using this method, write byte array. So in this method, we are writing a byte as it's an array of bytes, but that we can do by converting the source, converting this S1, S2, S3 in the form of a byte representation. So how to do that? You can have this getBytes method of string class. So S1.getBytes. So this will convert the corresponding string into a byte array form, right? This is nothing but a byte array. So this byte array is nothing but the byte representation of the string S1, and then you can use this byte array to write by using this directive about data.write, and inside it you can pass the byte form 1. So this is one way. You could have also used the simple write, the other write function, which is, let's say, this write bytes string S. So I can use this also. I can use write chars also. So you can see this, because this is also taking a string S, right? Write char string S. This is write byte string S, right? So the multiple ways are there. Is there anything else? Write UTF is a little bit different thing, so we will not worry about that now. Yeah, so these three methods are there. So any one of them you can use. We just wanted to display all the possibilities. So write bytes, write chars are very similar. I mean, you just pass the stream and that's it. Pass the string and that's it. But this having this byte representation form, it is something new. So how you can write using this byte array? So in order to write in the form of the byte array, you need to first use this getBytes method over here, and then using the getBytes method of the string class, you can convert the string into the byte form and then write that byte array. Okay, so this is just for displaying different functionalities. You might have just used the normal write char method and simply wrote the same string in the same manner. Okay, so yeah, so as a part of your exam and other OPP kind of places where you need to write code, you might not have to go through all of these getBytes and all that. Just simply write char, and then it will write all the, I mean, and pass the string, and it will basically write the string into the file. Okay, so anyway, so since just for demo purpose we have used this little bit twisted path by showing another way of writing. Anyway, so this is your getByte form of writing into the file using the data output stream class. Then the other one was print writer. So print writer, we know simple println method can be used to write into the file. So we are using the println method to simply write the sources directly into the file. Again, the print writer also has another way of writing into the file, which is directly using a write function. So that also you can use. So there are multiple ways of doing the same thing. That's the point that we are trying to make over here. So source not print dot write, I think, yeah. So write, you see all these methods are there of print writer object as well. So since you are writing a string, so you can put this write source 2. Right, so you can do something like this, same effect, no changes. Okay, the only thing is now println will print the next line. Okay, so that is one different thing. So println will not only print the source 2 into the file, but again after printing source 2, it will add a next line. So that source 3, the next print statement happens from a new line. right? So every source value, every whatever content is there in source 1, 2, 3 will be printed in a new line automatically inside the file. But if you use the right method, then this new line will not be added. It will be printed, a single long line will be printed without a new line, without any space. So if you want to add the effect of new line, this is what you can do, and this will ensure that the new line is entered into the file as well. So this is equivalent. So now the println function and the write function is equivalent if you do something like this, right? Anyway, so again, the thing is that there are multiple ways of doing it. So you can follow any one of them, right? So this writing is done. So at this point our writing is done. So now this is very important. See what happens here over here is, now once the file, once the data file and the source file are being written, the next part is what I will read from both of these files, arrange the data, match the famous line corresponding to the novel name, and then I will add it into the new file1.txt file, right? So basically I will read from the files which I have just written now. So in order to do that, I need to read the file, but can I read anything from the file now? At line number 40, after line number 40, what is the condition of these two files? Will the data be present in these two files which I have written just into, which I have just now written into them? Will the result of this fout or these write statements or print statements be reflected into the file? No, right? That's the example we have seen just a little earlier, that unless and until your file output objects or file output handlers are flushed out, the data will not be present into the corresponding files, and the flushing will only happen either if you do manually or if you are using this try with resources kind of thing, then it will only happen after the try block is over. But here we are inside the try block only, and we have only written it now, and then again we want to read it, right? So since now we want to read over here after line 40, so therefore we cannot do that, because since the try block has not finished, so the buffer is not flushed, and so the data will not be present inside the files. So therefore we have to now manually do flushing out of these two fout data and fout source. And once we do the flush out, and we are also closing these two as well, but at least if we don't close, that is also fine, but definitely we need to flush it. So this is actually important. This is where you have to manually do it, but still I would say that it is better to use the try block anyways, because there in this code it is not there, but there can be situation where you are working with multiple files, multiple handlers, maybe database handlers, maybe you have an SQL connection, maybe thousands of things you are working with, and you will need manual working only with this manually flushing or manually closing. Any such kind of operation you will only need to do with, let's say, 2 or 3 files or 2 or 3 situation, you have to do it manually. Most of the situation, if you have this automatic closure facility provided to us, then that will be good for us, right? Otherwise you have to do it for all the handlers. Fine, so keep this try anyways, and then if you need manual flushing out or manual closing of the handler, do it according to your need. So then what we are trying to do, let us see now. Since at this point at line 44 I can be assured of that the files are storing the corresponding data. So let us visit, we have not executed the file yet now, executed the code now, but assume that when we are at line 44 and the execution has reached line 44, you can assume that the two files are storing the appropriate data. Now we will read the data and create this. So what I mean is, what we want to create is, let me just tell this. So this, we have this, let's say, to be or not to be, that is the question. So if what I want to create is something like this. So right, so we want to do something like this. So in the file 1, so this is your file 1. Inside file 1, what will happen? We will have the name of the novel, which is, let's say, the first one is source 1, right? So this novel, Catherine's, whatever, yeah. So we have this file 1 will be something like this, and then maybe we can add a colon or something. I don't know what we have done in the code, but anyways, so let's say this one, have I added anything? No, but just normally. So we have this name, and then we will have the corresponding line, which is, let's say, this line, right? Control V, something like this. If you want, you can add a as I said, a colon or a dash or something to signify that this is the line and this is the book name, right? You can do anything like that. So what I want is basically this kind of situation. Then again, in the next line we have Shakespeare's Hamlet, so this will be written. So now you observe that these values are from different files, and now I am basically alternating between them like this, right? So you have to create, and for the third one also this will happen something like this. So this is what I want to create. Now how we will do that? So first of all, we will read from both the file. But how we are planning to do that? Suppose the file, let me just write it over here. The file data.dat, right? That is storing the statements, the famous lines. So how the famous lines will be stored inside that file? It will be just a collection of these lines, right? So let me just copy paste it. You will understand what I mean. So inside the data.dat, the data.dat file looks something like this. right? And then the third one will also be there. I'm not pasting that, but assume the third one is also over here. So the data.dat file, data.dat will look something like this. Okay, I'm not executing the code. We will execute the code at the end and see these things again. But let us now assume that data.dat will look like this. Now, how can I separate each of these famous line one by one? So you see, every time I'm starting with a new phrase, it is starting with a capital letter, quite usually. So I will figure out that whenever I'm getting this capital letter, then that means it is a new statement, right? Now you see what I do is, first of all, let us assume that our controller, our read pointer, right? So which the read handler. So when I'm reading a line, so by the way, I cannot use next line, I mean scanner.next line to read over here. Why? Because next line will read the whole thing until and unless it is getting a new line. So here you see that both the both these famous lines are stored on the same line itself. It is not on a new line, right? So therefore, since it is not done on a new line, I must make sure that I get the data properly, pick the data properly, and therefore next line cannot be used to read these lines. Fine. Yeah. So because here you see we have used this fout.write byte form. This byte form will basically write all the. So this is how the file will look, because this will be just copied like in the sequence of bytes, which is basically represented as string variable, but essentially that's sequence of bytes. So there will be no next line added automatically. But if you would have used any other function where next line might have been added automatically, like print line is used in this case, then we would not have to deal with all of this. But just for example, let us take this. So we have this much of we have this way the file is arranged like this, and we need to figure out that whenever I get a capital letter, that means it is a new line, and therefore I will keep it aside, right? So this is where you will see the use of our putback input stream will be helpful. Now why? Let us see this. So first of all, our control will start reading from here. So much of what was said, each one word we are reading, and then we are coming to this said word, and then first of all S will be read, then A will be read, then I will be read. So obviously you see that it will be done on a byte by byte basis. If we are reading it on a byte by byte basis. So since we will read it like this, right, we have to check the condition when a character becomes capital. So then D becomes, then we get D, then we get full stop, and then the next read will get T as the next read element, right? So after reading this full stop, the next read will read this capital T. So when we read this capital T now, okay, so now we understand, and that means this is a new, new line, not new line, a new statement corresponding to a different novel, right? So we are getting that since this is a capital letter, so it is a new statement. But now the problem is we have already read the capital T, and reading means it goes out of the stream. So it is already, we have already read it into the stream itself, right? So now what to do? In the next iteration, if you are using the same stream object, same read handler, basically whatever reading handler you are using. So in this case, it is scin.data, right? scin_data. So if I'm working with scin_data to do the reading, then if I read the capital T using scin_data as any one of the method, then T is already read. And next time that method is again used to read, the next character will be read, right? T cannot be read again in a normal stream. But if it is this pushback input stream, then we can put this T back into the stream, and then again when we are reading next time, then again T will be read. The way to push back that already read character is this unread method. Where is it? Yeah, this unread method. So this is only supported in pushback input stream. So now why it is necessary to push it back? Because I am reading the first line only. So this will be corresponding to one of the novel. Now if I read this T as well now, then this will be lost in the next, whenever I'm creating the entry for the next novel, the T will not be there. So I need to put the T back. So this is only supported by your pushback input stream, and that's why we use pushback input stream in this example, right? So we'll see that in the code now. So what I'm doing over here is we have a boolean is new variable. So this is basically a flag variable to figure out whether the current character is a start of a new line or not. New line, not new line. What I mean is a new statement or not. Right. So first of all, initially I'm setting it to true, because obviously for the first entry the first character will be definitely by a new line, a new statement that we are talking about. So therefore that will be capital. So I'm setting the is new to be true. By default it will be true at start, because that is the first line we are starting with. So then we are using scin source.hasNext, because this was a scanner class object. So scin source is what? scin source will iterate through the novel names. Because source is basically the file source.dat, which will store the novel names, right? So this is iterating through the novel names. So as long as we have some names left over in the sources.dat file, this loop will run. Now what I'm doing in the next line, I'm using fout target.print. So since now we have read the novel name, not read, we are inside the novel name class. That is the sources.dat class. Not class. I'm sorry for that. Sources.dat file. So inside the sources.dat file, we are now copying that particular string. The first corresponding to the first name of the novel. So scin source.nextline, since this is why we can use next line in this case, and in the earlier example I just told you that we cannot use next line. So as I told you earlier that this here we cannot use next line because all these statements are stored in a, I mean, without any next line used, like without any space used, just after full stop the new statement starts. So next line will read the whole thing altogether, which is not something which we desire, right? But here in case of novel names we can write next line. Why? Because the novel file or not the novel file, what I mean is the sources file, sources.dat file. So how will this file look? See, remember we use the println method to write into it, right? Here we used write method, so therefore we wrote it in this manner. But if you use the println method, then each of the novel names will be there. So novel name 1, whatever it was, then novel name 2 will be done on a second line. Because we are using println, so this ln will take care of the adding additional line after printing the data into the file. So since it is done on a next line basis, so therefore now while reading it also we can use the next line function to read appropriately. So this is something which is very, very important in case of file handling. You have to know what is the format of the data present inside the file so that you can use appropriate method to read it. Okay, you can use multiple read write pair of functions, I mean, to achieve the same functionality. But the thing is, you must be consistent about the type, about let's say the style you are writing the data into the file and the way you are reading the data from the file. If that style is not consistent, then there will be mismatch of byte and then the data will be corrupted. So be careful about how you are writing into the file and how you are reading from the file. You can read in multiple ways, you can write in multiple ways, but both of them should be consistent with each other. Right. So then here I can use the next line. So I'm using the source.next line, and then I'm just printing I have the about target file handler, which is basically the file handler for file1 class. Sorry, I'm again saying class, but I mean is file1 text file. So in that file1 text file, I'm directly printing. So here I'm using the print method. I'm directly printing the next line value from the sources.dat file. Right. So this will print the novel name into the file1 file, right? And see here we are adding this colon character as I thought I have done already. So this colon character we have good formatting. So the name of the novel will be there, followed by the famous line from the novel, and in between we have this colon. So this is how we are writing we are creating a complete string over here, and that string is being written into the file1 file. So this is the name of the novel being written into file1. Okay, so now once we have read the novel, corresponding to that novel, we have to pick up the line from the data.dat file. So therefore again we are writing this inner loop which will iterate through the data.dat file, and as we told that data.dat file we cannot use next line directly, we have to iterate through each character one by one, and because we have to figure out at what point the next statement starts. So we are using this is space available. So here you cannot use next as next, because as next is something which is used by scanner class, but the data file we used this data output, this pushback input stream. So pushback input stream does not support this as next and all those things. So in order to use the pushback input stream, we have this available function. So your pushback input is scin data will use the available function. So scin data dot available function. So it will tell if anything is there in the stream to be still read. So then we are putting into a space, and if space is greater than 0, then you read the first element of the scin. I mean, using the scin data handler, you are reading the first element. So the read function is used over here. So see the pairing here. We are using, in case of pushback input stream, we are using the read function. And while writing into that, we use the write function. F out data write, scin input data is read. Where is that? Yeah, this read, right over here. So write read pair, and here in case of the sources, we use the this next line to read, and while writing into the source, we use the println to write. Right. So please see this pairings very properly. Okay. Now, so once the data is available, space is available. Now I've read the first character. Now I'm putting the if statement check. So if it is a capital letter or not. So 65 is the starting of capital A ASCII letter, and 90 is capital Z ASCII letter. So if the data is, if the character is between this, so read will basically read each byte. So if you see the definition of read, it is read the next byte of data from this input stream. The value byte is returned as an int in the range 0 to 255. So this is basically that ASCII code of each of the byte sequence, and therefore we are basically reading it character by character. We are reading it byte by byte, but essentially since it is written in the form of an ASCII code, therefore that number can be directly considered as an ASCII value, which is basically then I can, therefore I'm using that ASCII value 65 and 90 to check whether it is an alphabet capital letter or not. Okay, so anyway, so here we are checking that if the alphabet is a capital alphabet, but then again I'm adding an additional and statement where not is new is used. Why this is required? Because capital alphabet means a new statement is starting. So I can just stop over there. I mean, I can just say that, okay, since I've read the capital alphabet now, why? Because this read has read the capital alphabet. In the next line, I'm seeing that, okay, it is a capital alphabet. That means it is a part of the next line, next statement. So I can directly just do this unread over here, right? I can unread the read data, which is a capital alphabet, and just get over with it. But why I'm using that is new flag variable? This is new, as I already discussed, this must only happen when the statement is a new statement. So in order to allow that to happen, therefore we are using this variable which we will toggle accordingly, so that every time we start this only for new statement and not generally in the between. Right. So if data not is greater than equal to 65 and data less than 90 and is new is not is new, that means what does this not is new mean? That it is not is new is true, then only we will enter this if statement, right? So basically when is new is false, then only we will enter this statement. So then we are getting, so that means what? Whenever you are starting the first read, when is new is true, these lines will not be executed at all, right? Because that is already we are starting a new statement first time, and therefore we don't want to, go into this statement. So if you just go through it, you will understand. So then what we are doing is inside it we are setting the is new to be true, because now the new statement has started. In the next iteration, I will start with reading a new statement. So is new is true. Therefore, I'm setting the is new to be true, and then I am doing the unread part, which is the USP of pushback's input stream. So now I am putting that capital letter which I have read, which is basically a part of the new statement, into the stream back. So that is done by this unread data method, and then I'm breaking, because now I have finished reading the part corresponding to the first novel name. Right, the dialogue, famous dialogue corresponding to the first novel name has finished at this point. Therefore, I'm breaking out of the inner while loop. Why? Because since I have read a new capital letter, that means I've already moved into the new statement. So I will break now so that I go to the new novel name. So I'm breaking out of the inner while loop, and I will go out of the, and I go out to this new while loop, and this while loop will again read a new novel name from the sources.dat file, and then again I will just go to the inner while loop again, the new inner while loop, which will correspond to read the new statement corresponding to that particular novel name. And now this time when I'm going to read the new statement corresponding to that particular novel name, it will again start with the capital letter itself, which I have read earlier, because I have done the unread method over here. I will not miss that capital letter. But if you wouldn't have worked with a file input, pushback input stream, then in the next read, since we are using the same read handler, SCIN data, the read handler would not have read that capital letter again. Got the point? Anyways, so now that is done, and in the else part we are saying that is new is false, so as to continue the iteration. This is a continuation condition, and at this point we are writing. So f out.target.write. So each character by character I am writing. So what this write will do? So every time, so let's take the first iteration, right? So just assume that this is the first capital letter M I am currently starting, capital M. So is new is true. Then inside this I went SCIN data is capital M, and data is greater than 65, you are true, less than 90 true, but is new, not is new is false, because is new is initially set to true, so not is new will become false. So I will not go inside this if method, if block. Inside the else I will come, and I'm setting the is new to be false, and I'm writing the target into the data. So M will be written. So at this point your M will be printed into buffer. So we are not printing into file, we know that now. So we are basically done the printing of M into the buffer. Okay, so M is printed. Now is new is set to false, right? So again, after the else statement, we see the if space is available. Obviously space is available, because again we still has, so basically we have this from here to here, all this space is available. So then the next thing to be ready is the small u, right? So okay, then I come over here inside the while loop's next iteration. So I SCIN data.read reads that small u, right? And then it is saying that if data is greater than 65, so it will be greater than 65, but it will not be less than 90, because small letter ASCII value is starting after capital letter ASCII value. I think 97 or 98 it starts. So therefore this condition will not hold. Then again I will not execute this line. Then again I will come here and set, again it is basically it was anyway false, but again I'm re-entering false into is new, and then again writing the u. So in the second iteration u will be printed into the buffer. Okay, so you see, likewise we will iterate through it, and when the next capital letter comes, right? So when I'm over here, when I'm at T, right? So T will be, this condition will satisfy in case of T, and is new is what? Last it was set to false, right? So since it was set to false earlier, now is new not of false will give true, and then we will execute these 3 lines of code. Now this means that I know that since I have now entered into this part of the code, which is the if block, then I am currently going to read a new statement. Therefore I am setting the is new to be true, and then I am unreading the data, because it is a part of the new statement as already discussed. And since I have already finished working with whatever I was reading corresponding to that novel name, therefore I am breaking and moving out to the next novel name, which is, my breaking means break always happens from the inner loop. So I am moving out of that inner loop into the outer loop. So here is where, after this break statement I will come at this line, and not this line, basically this line. I will check the has next condition, and then again we are going for the next novel name to be read from the sources.dat file and printed into the file1.dat file, and then again we will repeat this while loop for the next novel name, data corresponding to the next novel name again. So now I hope this is understood, and we have this IO exception for obvious reasons, right? And yeah, so that's it. Now here whatever I am writing, or this write is there, right? Here I do not have to flush manually, because see, we will see the file at the end of here. I am not writing, reading anything again after this write is done. After this write is done, I am not reading anything again, which was happening earlier in the code. But since the file we will see only after the code has terminated, therefore we don't need to worry about flushing manually. It will be taken care by the try with resources block. Fine. So let us now execute it and see what happens. So the code has executed properly. We have source.dat, data.dat, and file1. So let us see data.dat, source.dat, and file1. Right, what is that source.dat and data.dat? Yeah. So see, these are the files as we have already discussed. So this is the data of the data.dat. So when you are writing it as a byte stream, right? This write function, right? Byte stream. So they are creating this file, as you can see, continuously without any space or anything, just like a sequence of byte it is written. Data.dat, source.dat, since we are using the println method of scanner class, it is written in separate lines, right? And then file one, this is the way we are creating file one, the name of the book, colon followed by the corresponding name of the dialogues. Okay, fine. So this is how you can work with files, and I hope the idea of why this unread method is helpful and why the importance of why we have used the pushback input stream is properly communicated by this code, because this if you read this capital letter once, then every time in the, let's say, file one, once I read this capital T as a part of the previous code, I mean when I was iterating through this line, then once again if I use any other kind of stream, then this T would not have been read and the file would look like something like this in the next iteration. So that is the ultimate selling point of your this pushback input stream, right? Pushback input stream is helping you with that by using the unread method of pushback input stream, right? Okay, so that is done, and then we will go to the next code. This is, I will be very brief about it. So there is nothing, it's just two methods, two classes. Only thing is now we are writing, rather than writing any primitive type or strings, we are now writing objects. Only thing that you have to do is implement serializable. Serializable is again a marker interface. As we have already discussed, marker interface does not have any method. They are just a way to indicate to the Java system, because I mean there are some internal reasons of why it is done, but anyways we will not go into that. So this is just a way of informing Java that okay, so I want to serialize this class objects. So these class objects, so whichever class is implementing serializable interface, we can write these objects into a file. Everything else is explained in a quite detailed way in the slide as well, so there is nothing new to discuss over here. So this is just a code, you guys can go through this code and work on it. Okay, just normal class. Only thing is you have this implement serializable. There is no method to be overridden also, unlike clone. Normal, everything is normal. Only new thing is here we use these two new classes, object input stream and object output stream. Right? So just like different stream input and output we see in like pushback input stream, buffer input stream, data input stream, accordingly data output stream. So all these things we have seen, right? So likewise, these are again two new input and output stream for which handles object writing and reading from files and to the files. Okay, so file and input output stream will obviously be there. On top of that, we are wrapping it around this object input output stream, and then we are using it to write objects just normally. And the function we are using is write object, right? This flush concept is also discussed, and the function we are using to read the object is read object. Okay, that's it. And then you are reprinting the value. There is nothing new to discuss over here. Just you are using these two new classes, object output, object input. We are using the write object and read object method. Read object method to display and to write and read from the file. And only thing, the new thing is here you are using this marker interface called implement serializable to mark that this classes might be written into the file. I mean, this class objects might be written into the file. So there is a sample code. We will release this code at appropriate time. And anyways, you can anyway go through it and understand what it is doing. Simple task. Okay, fine. So that's it for this week's sessions as well. We have discussed different file handling concept with appropriate examples. So I hope this will be helpful for you. Thank you all. And we will be meeting in week 10 code walkthrough session.